Okay, so dear students, so we are gonna learn today about one modeling technique is widely used. So this is one of the most basic modeling techniques, but this modeling technique used in like so many epidemiological research. So what is the name? Today we are gonna learn about the Logit regression modeling. So what is the name? Logit regression. Not just not. Oh yeah, regression. Modeling, right? So definitely we are gonna learn this modeling using R, okay? Using R. So I request you, if you don't hear me clearly, so you can just tell me, okay? Sir, we cannot hear you. So anyway, so today's class, the topic of our today's class is Logit regression modeling using R. So you are learning about the categorical data analysis. So mostly our real life problem as far as the disease is concerned is mostly the disease outcome are categorical or dichotomous. You even can say the dichotomous outcome variable mostly occur in the disease occurrence, right? So the logit regression, or you might say this is a logistic regression, you might say sometimes, right? So logistic regression, also called a logit model, is used to model dichotomous outcome variables. Dichotomous outcome variables. So consider two examples. Example one, suppose we are interested in the factors that influence whether a political candidate wins an election, right? So there are two outcomes of the winning chance of the election, right? So the president might get elected, or he or she cannot be elected, right? The outcome response variable is binary here. That means elected versus non-elected, win versus lose, right? The predicted variables of interest are the amount of money spent on the campaign, right? And the amount of time spent campaigning negatively, and whether or not the candidate is not perfect enough. So there are a lot of factors you might consider for your research of interest, right? So this is a typical example. So the next important example, based on what we are gonna model it out, the second example I'm gonna tell you right now, this example is very important because today's class or the modeling or the R codes are based on this example. So what is this example? Consider a researcher, right, is interested in how variables such as GRE. What is the meaning of GRE? You don't know?
Graduate record education.
GRE.
Examination.
This is called the graduate record exam, right?
Exam
score. Yes. So you can say this is a GRE scores. So graduate record exam score. So I can consider another example, another variable, right? GPA. So this variable is nothing but grade point average and prestige of the undergraduate or graduate institution. That means the ranking of the university. So how many variables I have considered right now? I have considered three variables. Number one is the GRE. Number two is the GPA, right? Finally, the prestige of the institution. That means the ranking of the institution. So do you have any idea, based on these three variables, what might be my outcome variable? Do you have any idea? Okay, I'm giving you I'm giving you or pronouncing the variables again. So what are those variables? I just talked to you. Number one is GRE, right? Number two is GPA. And number three is the ranking of the university. And my question is, what might be the potential response variable here, or the dichotomous variable here? Do you have any idea? Because I gave you already the predictors, right? I gave you the independent variables already. Now it's your turn to make your own response variable. Definitely I'm going to tell you, but I just want to test you. Can you guess or can you make the dependent variable from these three variables? Try.
Sir, sons or scholarship? Yes, no.
Yeah, might be. You are very close. You are very close. You can try, or the other students can try. Definitely the response variable is gonna be the binary response, right? The response variable is gonna be the binary response. So I'm telling you what should be or what could be or what might be the response variable of interest here. No, you cannot tell. It's the admission, whether you are gonna admit or not. The same thing, Mr. Arman, is quite okay. Like the scholarship, yes or no, something like this. So admission, whether you are going to admit in that university or not. So your admission choice, right, depends on three variables are here. Number one is the GRE score, right? Number two is the GPA. What the GPA you had in the undergraduate level? If your intention is to get admitted yourself for the graduate study, right? Or maybe you are interested in undergraduate study, then you can consider the SSC and SSC GPA, right? The schooling GPA. So GPA, GRE, and the final one is the ranking of the university, right? So these three factors might affect your admission status or the choice of the admission, whether you are going to admit in that particular university or not, right? So what is the nature of the example? In this example, what we can see, we have three independent variables, or we have three predictors, or we have three explanatory variables, right? Or we have three regressors, right? Or we have three exogenous variable, right? So a lot of names, lot of names of independent variable. And what is the response here, or what is the outcome of interest for our research is here? You have to estimate, right? You have to estimate your admission choice, or you have to predict your admission choice, right? Or if you want to find out the influential factors that might affect your choice of the admission for a particular university, right? So for this example, what you can do, you can use a typical or a very popular regression modeling. This model is called the Logit regression model, or sometimes you can say this is called the logistic regression modeling, right? So now we'll just try to see the examples in the form of numbers, right? So we want to see the data, what we just talked about the example, right? So the data we are gonna read right now based on the second example, right? So how we can read the data in R, any idea? So there are many ways you can read the data in R, right? Suppose now I have the data in my desktop, right? So I am gonna read the data from the desktop, right? So you have to add the name of the data, right? So suppose I'm gonna use, or I am gonna use the name of my data. So that data like my data, right? So you can use the, what is the name of the symbol? Anyway, you can also use the equal, right? You know better than me right now. So I'm going to read the data set. So the command should be read dot
table
CSV, right? So now
CSV.
you have to read the data from my desktop data source. So how you can read? I think you already know this one. So I have used the command read dot CSV. Suppose my data is like the CSV, and I'm not really sure where is the exact location of my data, right? So how can I read the data? So you can just use file dot choose, right?
Yes.
So if I'm wrong, you can remind me, sir, you are doing wrong. So this is the programming, right? You have to help me, and I'm definitely help you, right? So at the end, we can reach to a like successful output of our coding or programming, right? So what you can see from here, so I used a name of the variable or the coding or the sentence, right? Or maybe the data set name. What is the name of the data set? My data. Okay, now I'm going to read the data set. So what is the command? Read.csv. I'm using one command and lots of commands, right? I'm just, for the time being, I'm just using one command. So file.choose, right? And you don't know, you just using the computer to look at the file, right? So the computer will automatically look at your file. So header is equal to true. You can just write T is also fine, right? So let's see it's work or not. So let's try to Okay. Sometimes you see it's not coming, but you can see in my like listen in my desktop, right? Or computer here. So it's already here. So maybe my data is in the desktop, right? So maybe there is a downloaded data over the year. So try to find, maybe the name is binary or something. Yeah. So this is the binary data. So I am gonna read the data set. So the second example, right? This data is about the second example I just told you. So how can I see the data? Do you know?
Around my data.
Yeah, you can just run the my data, or if you want to save your time, just you can write this one sentence, right? In one sentence you can do a lot of programming. So my data, the same is already here, right? So my data, let's take a look. Okay, what happened? You see why is happening? Because this is the same command, right? The laptop is telling me read
Yes.
the data again. So I have to read the data again, no problem. Okay, you see now this is the thing. Okay, so one command is here. So there is a command here like this, reached maximum. Okay, omitted 150 rows. I think I told you already in any of the class you attended already. Suppose you want to read the all the data sets you want to see. What is the command then? Can you remember?
View data.
Print.
View data.
What is that?
Sir, view data.
View my data.
What is the command?
View. Sir, command will be
W.
view bracketed my data.
Okay, let's try with the view, and maybe I can copy it so I can use several times. So view my data. Let's see. Okay, so this is the one. Yeah, it's a good thing. Okay, so how many variables are here? You can see. So you can see
4 variables.
4 variables. Number one is the admit variable, right? Number one is the admit variable. That means you are going to admit in that particular university. So how many, maybe a lot of data, I'm not sure. So you can see the dimension of the data also. How many variables are here, right? How many observations, how many row, how many column, how many variables, you can just see. So for the timing, I'm not going to discuss about those things. So the second variable is GRE, third one is GPA, and the final one is the ranking, right? So what is the response variable here? Response variable is the admission. Response variable is the admission. That means whether you are going to admit in that particular university or not. So what are the predictors are here? So there are 3 predictors: GRE, GPA, and ranking of the university, right? So we are going to model it out. I'm talking about the logistic regression model or the Logit model, right? So yeah, this is the data. Okay, so another thing, maybe you can use the heading or head data, right? Let's see what. Okay, so this is, what is this? I use the I use the head, then head of data. So my data, right? So what is this?
Sir, this function is used because to see the past 6 observation of the data.
Past?
Past 6 observation of the data.
Are you sure?
Yes, I think.
8, right? Let's see. So the number 6 is 760. 760. So yeah, 760. Good. So what is the function of this command? Just that we want to see the headings, right? We want to see the headings of the variable, or if you want to just see the variable name, right? Like how many, what is the name of the variable? Maybe then you can use this function, head of my data, right? So we have 4 different variables are here. Okay. So because our intention is to run the logistic regression model or Logit model, so the good thing is that what you can do, you can summarize your data. So as a basic statistician, right? It's a good thing whenever you get some data, just try to play with the data. What I said, try to play with the data. Try to see something inside the data. What are some of the basic statistics you can explore from that data set, right? So what you can do, you can just use a command summary, right? Summary of what? Summary of your data. Okay, so let's take a look of our summary of the data. What problem? It's not coming. So maybe head, right? Then
Sir, you put the S capital.
really? I don't think so. Oh yeah, maybe. Good. You see, so this is the thing you can see, right? Okay, so this is the summary. So could anyone can explain the summarized result here? Could anyone please explain the summarized information from here? What do we get from here? Don't know.
From the data, the highest GRE score is 800, and the minimum GRE score is 220. Highest GPA is 4, and the lowest GPA is 2.2.
What? Anyway, so these are some of the basic statistics you should know, right? I think you already know about the minimum value. So it's a normal thing like for the GRE score, what was the minimum GRE scored by the students, right? You just want to know also what is the maximum GRE score. You might want to know, right? What is the maximum GPA score and what's about the minimum amount, right? The first quartile, median, mean, and the third quartile, right? That means the 25% of the students, what about their characteristics, right? Like the 75%, more than 50%, less than 50%, and what is the average scores, right? Something like this. So you want to know some of the basic things. So if you want to know some of the basic characteristics of your data or the summarized information from your data set, so what you can do, you can just simply use a function summary. So this function will give you the summarized information of your data sets, right? So you can play with your data. It's better. A statistician should play with the data. You have to play like there's so many statistics you can calculate, right, from your data set. So my next question is, how can you find the standard deviation of your data? Because this is very important, right? So like the standard deviation, the variation, overall variation, suppose in my class, suppose you all students, like 56 students attended in the GRE score exam, right? GRE exam, even IELTS exam, right? A lot of exams. And what was about your score? Overall, if I want to conclude, what is about my class students, right? How are they, like? What is the characteristics of my students? Are they really good, right? So I want to make an interpretation. I want to make a conclusion, right? I want to make a summarized summary about my students. So what you can do, you can just calculate the variation, right? You can just calculate the standard deviation of each student, or maybe you can overall student, I'm sorry, or even you can calculate the mean or average, right? So my question is, how can you calculate the standard deviation from this data set? Do you know anyone?
To use the function of SD.
What is that? SD, right? So I'm not sure because you have a lot of data set, right? Now you are not calculating only one variable. Okay, let's try with the SD, right? Will it work?
Maybe so.
You see?
Okay. If we want anyone for any standard deviation, then we can add here to my data third bracket of comma 1, 2, 3.
Okay. So this is a very complex code. So I'm gonna give you a very simple code, right? So you just say S for standard deviation, right? So you are telling the computer, or you are telling your code generator, standard deviation apply. Where you have to apply the standard deviation? You have to apply the standard deviation for your data sets, right? Let's see. And what you are gonna apply? Standard deviation, SD. Okay? Apply on my data and try to find out the standard deviation. Let's see what happens here. So we found standard deviation for each variable. You see, for admit variable or admission variable, we found 0.46, GRE it's a lot of variation. That means GPA 0.38 and ranking 0.94. So could you please somebody explain the result? What is this? If I want to select the best students, like I want to conclude my students from my class are very good or not. Okay, which variable is capable enough to answer my questions is here. Any idea? Quick. If you don't know, just say something because it's recording, you know. You have to be interactive, like the class should be interactive. Anyway, you can just take a look over the variation, right? If the variation is very small, that means you are very close to each other, right? That means overall variation is very less. That means all the students are very similar as far as their intellectual capability. If I want to measure their capability based on the GRE or like the other scores are here, right? So even GPA. So you can just take a look on the standard deviation, right? Anyway, so the next thing is that contingency table, because we have four variables, right? So we can draw a contingency table from here. So if you want to make a contingency table of the categorical outcome and predictors, right? Because we have only we have only three predictors and only one categorical outcome. That means the admission, right? Or admit. So you can create a contingency table from here. Or if your objective is to see, is there any zero cells, right? Like, is there any zero value in any cells, right? So you just want to create a contingency table and try to take a look over the table. Is there any zero value or not, right? Or zero cells or not? So how can you can do these X steps, right? So then on X steps on, right? Admit plus rank. Okay, consider okay, let's see, just based on these two variables. So what is your data? Your data is my data. Okay, so this is the command. Let's try to run the command. You see, this is a contingency table. So how many ranking? There are 4 ranking, 1, 2, 3, 4, right? So as I told you in my previous class, in the row, right? In the row or in the column, maybe, right? The column is the response variable. In the row, it's not correct because only 2 variables is here. Anyway, so I just started to create the contingency table. And what do you think? This contingency table is made from all the data. I want to know, is this contingency table used all the observations from your data or not?
Yes, sir.
All the data? Now try with the GRE, right? Now try with the GRE. So now try with the GRE, right? Let's take a look. What's about the output is here. So how many levels of our output here? Why the level is too much? It's maybe because the category of the GRE score, right, is a lot of categories comparing the ranking. So we can also conclude another contingency table from another variable. What was the last variable?
Rank.
Rank we already used. What is the remaining one? GPA, right? So we are going to create another contingency table. Let's try a look. Also, this is the thing, right? So you can play with the data, no problem. So we just try to construct a contingency table, right? So nothing else. So then what we can do, our main concern is to model the Logit model or logistic regression model, right? So today I am going to show you in a different way. In the logistic regression, the link function, you can use a several link function. Okay, so I want to show in a different way today. So how can I run the logistic regression model using the GLM? So now Logit model, right? Logit model using GLM. I already told you about the GLM. What is GLM?
General linear model.
Generalized.
Generalized linear model.
Generalized, right? Something like this. Generalized linear model. Generalized linear model function. So what we are gonna do here, we want to estimate the Logit model, or we want to do the modeling, logistic regression or Logit model using the GLM, generalized linear function, right? So for that modeling, we need to convert rank to a factor to indicate that rank should be treated as a categorical variable. You understand what I mean?
Yes.
I told you, you have to convert rank variable to a factor, to indicate that rank should be treated as a categorical variable. Because we have only 4 categories here. 1, 2, 3, 4. You did not check the data. I think you already, you see how many ranks? Ranking 1, ranking 2, ranking 3, ranking 4. So what we are gonna do, we want to convert the rank variable as a factor to indicate that rank should be treated as a categorical variable. How can we do this? How can you do, any idea? How can you do this? Any idea? So this is called the extraction from your data set. Suppose, what is the name of my data set? My data. Sorry, my data. My data. So from the my data, you want to use one variable, suppose rank. Suppose rank. So you can use the $sign. Anyway, I'm just using the name. So I'm using the rank variable is here. So what you have to do, you have to convert as a factor. So I am going to convert the rank variable as a factor. So this is the factor function, right? Then from where you want to convert rank from my data, from, this is called the from. The $sign is the from the, so you are selecting one variable from your whole data set. So I think we got the factor, right? How we got the factor? We got our factor made a conversion, right? What the conversion was about? The conversion was about the factor, the rank variable, we have converted it as a factor, right? So I think no need to run. Okay, let's try to run this one. Okay, so it's already got the factor. So let's try to see about the output, right? So this is the factor already. So this is the like the matrix. Anyway, so how many levels? The levels is 4. So now we are gonna run our Logit model. So what is the Logit model? Suppose say my Logit, because we are applying to my data. So this is the name. You can create your own name, no problem. So my Logit, you are doing the generalized linear modeling, right? GLM. GLM. So how you are applying GLM? So what is the response variable for your GLM? Admit, right? Admit on the predictors. So you have 3 predictors, GRE plus GPA, right? Plus a rank, where data is equal to my data, right? And family, what is the family? Any idea? What is the probability distribution you can use for this analysis? Any idea?
Binomial.
Very good. The family is equal to binomial, right? So since we gave our model a name, my Logit, R will not produce any output from our regression. In order to get the results, we use the summary command, right? You have to use the summary command, otherwise you are not going to get the full result. Anyway, we just try to run this command and try to see what happens here. So what's the problem?
My data spelling is wrong.
My data spelling is wrong. Very good. Now try. Okay, so I think it got accuracy. as far as the output, right? So anyway, so try to run this command. Okay, so this is the, like, you just got the estimated value, like the parameter estimation, right? What is the coefficient for GRE? What is the coefficient for GPA? What is the coefficient? You see the ranking factor. That means rank 2, rank 3, rank 4. What's about the rank 1? No need the ranking 1. Huh? Anyway, you can explore, right? So the better thing is that you can summarize your model. So you will have a lot of information there, right? So what you are going to summarize? You are going to summarize your whole model, what you did, right? So I think you are going to get a lot of information from this summarized data. You see, this is more good. If I can explore it like the bigger size, you can see. So this is the summarized. So everything is there. Everything is there. So I thought I told you in my previous class or any of the classes about the logistic regression modeling interpretation, right? So now you have a specific 3 variables and specific 1 response variable. Now tell me, what is the interpretation of this one? Quick, please quick. Be quick, otherwise the class is going to be very long. Okay, maybe you can explain from here, from the result. What is this one? What is this one? What is the last one, right? So you can just try from here. What is this one?
Summary of the residuals.
Yeah, but what is the objective of this deviance residual? Anyway, so this is a measure of the model fit. This is also a measure of the model fit. So you used a model and you want to know about the fitting of the model, right? How fit the model was. Okay, you used right now. So I think the deviance residual is nothing but a measure of the model of fit, right? So you can also see the distribution of the deviance residual for individual cases in the model using this result. Okay, anyway, so the important thing is here. Important thing is here. So try to interpret the coefficients. How many things are here? Somebody tell me how many things are here. So we have here the coefficient, right? What is the coefficient here?
GRE,
The intercept is the minus.
Coefficient is the estimated value. -3 to -1, right? So these are the coefficient. Then what are the standard errors of each coefficient? These are the standard error, right? What is the Z statistic? This is called the Z statistic. Or sometimes you can say this is a world Z statistics. One man, right? The world named world maybe discovered this test. So you can say this is a world Z statistics. And the final column is nothing but the associated p-value. Associated p-values, right? So what you can conclude from this whole table? Any idea?
So all the explanatory variables have a significant effect on admission.
Okay. What's about the GRE and GPA?
So GRE and GPA have positive effect on admission at 1% level of significance.
There's the problem, like you just want to memorize whatever you have learned, right? Try to explore. Here you see a lot of problems. We have no problems for the interpretation for GRE and GPA because these two variables seems individual variable, separate variable, no problem. Problem is the ranking. Okay, problem here is the ranking. So the way you interpret it, I think is not correct. So I think you should interpret GRE and GPA. You should focus on the GRE and GPA, okay, based on the ranking. Based on the ranking. Anyway, you can try in your home. It's a normal thing. For the ranking, how many factors? Ranking already converted into factors, right? So for ranking factors, maybe you can explain GRE and GPA, right? I think that is a very logical things. I'm just giving you the clue. You should try in your home, right? Okay. Anyway, so what is the loss? If I want to tell you overall, what is the interpretation of logistic regression coefficient? Generally, the logistic regression coefficient give you the change in the log odds of the outcome, right? This coefficient is gonna give you the log odds of the outcome for a 1 unit change or 1 unit increase in the predictor variable, right? I tell you again. What is the overall interpretation of the coefficient? What is the overall interpretation of the coefficient? The overall interpretation of the logistic regression coefficient is that the coefficients used to give the changes in the log odds of the outcome for a 1 unit change in the predictor variable. That means 1 unit change in the predictor variable. How much change in the response variable? That means in the admit variable. These are the values. These are the values. Okay. So now let me know about the interpretation of GRE. Somebody tell me what is the interpretation of GRE? I understand this is a significant variable. GRE and GPA is a significant variable. That is true. That means there is a significant effect of GRE and GPA on the admission. That is there is no doubt about this conclusion, but I want to know the interpretation of this one, GRE, based on the coefficient. Tell me, somebody tell me, please.
For 1 unit increasing of GRE, the admission will be increased 0.0022 units.
That's why I told you, please listen to me very carefully. What I have told you in my previous sentence, I again tell you. The logistic regression coefficient give the change where in the log odds of the outcome. So you have to keep in mind, or you have to be very careful. So I'm interpreting like you have to be very careful here. Log odds of the outcome. So the last student, you can try right now. Just change the outcome. You have to use the log odds of the outcome. Before the admission, you have to just use the log odds. Try again. Try again. Maybe you don't understand what I mean. Okay, I'm writing. Log odds of admission versus a non-admission. But now try to interpret quickly. You were correct, the last student, you were correct, but you need some adjustment of your correction, of your interpretation, right? So this is the adjustment I just give you. You just use this sentence as far as the response variable, and the other things are okay. The last student, please repeat your interpretation again.
For 1 unit change of GRE, the changes of log odds of the outcome will be changes 0.002264.
You just see here what I wrote here. Try to use all these things for your response variable. Try again. Quick.
Okay.
Please try another student, please. Whatever you told, just try to use all the things are here.
Sir, 1 unit increase in GRE, the chances of admission.
I wrote for the response variable. Everything I wrote here. For the response variable, I wrote everything here. For the remaining sentence, you are okay. So I told you, try to accumulate or try to use my statement in your statement. Then the statement will be complete or fulfilled. Try again. My God.
Sir, can I try in Bangla?
Yeah, I can try in Bangla.
Sir, সম্ভবত স্যার যে যারা এডমিশন দিবে তাদের চান্সেসটা যারা জিআরই করছে তাদের থেকে মানে করেনি তাদের থেকে 0.002 তারা মানে বেশি এগিয়ে থাকবে এরকম।
You are correct partially, but there's the problem of our students. They cannot interpret a very simple things easily. That's the problem. And you are gonna use a lot of unnecessary terms are here. Anyway, let's I'm writing. Somebody please read out my words, what I'm writing.
For every unit, change in GRE, the log odds of admission versus non-admission.
What happened then?
Increases 0.002264 units.
Okay, just write. Okay, I'm not writing all the things. Always try to write only 2 digits or maybe 3 digits if there is a problem, right? You understand what I wrote here? Now tell me about the GPA. Try to interpret for the GPA in the same way. For GPA, what we got? 0.80. Tell quickly.
For every unit change in GPA, the log odds of admission
For
versus non-admission increase. 0.804 units.
Okay, I'm just slightly changing my sentence structure, okay? Just changing slightly. Admitted, right? So it's gonna be admitted where? To a graduate school. To a graduate school, right? Increases by, now you don't need to use this one. Increases by how much? Increases by 0.80. Okay, 0.80. Okay, this one is fine. Now try for the ranking variable. If anybody can interpret the ranking variable, I'm going to give you the full marks for quiz. Now for the ranking. If anybody can interpret accurately for the ranking variable, I'm going to give you the full marks for the quiz marks. You don't need to attend for the quiz exam. If you can answer the interpretation, right, for the ranking variable. Yes.
For every unit change in rank, the log odds of being admitted to graduate school decreases by 0.675443.
Okay, I'm writing. If you are correct, okay. If you are correct, try to match with my writing with your thoughts, right? Having attended an undergraduate institutions, right, with a rank of 2 versus an institution with a rank of what? 1 changes the log odds of admission by how much? Minus 0.675. why we did not incorporate, why we did factorize the ranking variable. Now you understand. I told you whenever you have categorical explanatory variables, right? You should have a reference category. You remember? You should have a reference category. So ranking 1 is the reference category because there is no category in GPA or GRE. Normally in the logistic regression model, right? If you have explanatory categorical variables, then you need to set up a reference category for one category. Then for the rest of the categories, what you can do, you can compare the rest of the categories with your assigned reference category. That's why the ranking 1 is missing here. Okay, you understand or not? You understand the interpretation or not? I think you,
sir.
huh?
No, sir.
Which one you
Sir,
didn't
please
understand?
explain again.
Which one you didn't understand?
Rank.
Last one, sir. Last one, sir.
Last one. Okay. So in the last one, how many ranking overall in our data set?
3, sir.
Overall, like the real data set, we have 4 ranking. We have
4 rankings, sir.
Ranking 1, ranking 2, ranking 3, ranking 4, right? So I told you in logistic regression model, when you have categorical explanatory variable. Now tell me how many variables, explanatory variables are here? Tell me quickly. How many explanatory variables we have here?
5.
Explanatory. We have 3 explanatory variables. 3. Number 1, GRE, number 2, GPA, number 3, rank. What is the difference? What is the type? What are the differences among these 3 explanatory variables based on the category or based on the characteristics? Could you please answer? I told you. What are the differences?
Sir,
I want to know the type of the variables are here. Tell me quickly.
For rank, there is 4 categories.
I really don't want to know from you the explanation. I told you what is the type of the variable. Don't explain, just tell me the name of the variable.
So discrete and continuous.
Which one is discrete?
Discrete is rank.
Good. So better is a categorical variable, right? It's a categorical variable. Categorical explanatory variable, but the other 2 are not categorical. The other 2s are quantitative and it's really continuous. Okay. So the problem is here. So for GRE and GPA, you don't have any problem for the interpretation. But for the ranking, it's really a problem because you have a categorical variable here. So you have to compare within the categories. You have to compare within the category. That means, suppose you have 4 universities, Dhaka University, Jahangirnagar, Rajshahi, and Chittagong, right? So you have to compare, suppose Dhaka University. You are going to compare Dhaka University with what university? With the rest of the university. Jahangir University, you can compare with other universities. So you have to keep one university constant. That means this is called the reference category in logistic regression model. So when you have categorical explanatory variables, right? What you have to do, you have to fix a reference category for one category. For the rest of the category, you can compare those category for one category. আচ্ছা আমি একটু বাংলায় বলি তোমাদের এখানে 4টা ক্যাটাগরি আছে রাইট তোমাকে এখন ক্যাটাগরির সাথে তো ক্যাটাগরির তুলনাটা করতে হবে না হলে এখানে ইন্টারপ্রিটেশন তুমি কখনোই করতে পারবে না তো তাহলে এখানে কি ইন্টারপ্রিটেশন করতে পারবে না তো এখানে তার মানে র‍্যাঙ্ক 1টাকে আমরা রেফারেন্স ক্যাটাগরি ধরেছি এটা মান হচ্ছে 1 এটার অডস রেশিও কোএফিশিয়েন্ট বা অডস রেশিও মান হচ্ছে 1 তার মানে এখানে প্রথমটার জন্য র‍্যাঙ্ক 2 এর জন্য ইন্টারপ্রিটেশন হবে যারা আন্ডার গ্রাজুয়েট অ্যাডমিশন নিয়েছে র‍্যাঙ্ক 2 মানে 2 নাম্বার র‍্যাঙ্কের ইউনিভার্সিটি কার সাথে কম্পেয়ার করে র‍্যাঙ্ক 1 এর সাথে কম্পেয়ার করে তাদের চান্স কত অ্যাডমিশনের চান্স হচ্ছে মাইনাস মানে তাদের অ্যাডমিশনের চান্স কম এটা যদি বাংলায় আরেকটু সহজ করে বলি, যারা 1 নাম্বার ইউনিভার্সিটিকে কনসিডার করে নাই, 2 নাম্বার ইউনিভার্সিটিকে কনসিডার করতে চায় অ্যাডমিশন হিসেবে, তাদের অ্যাডমিশন হওয়ার প্রবাবিলিটি বা পসিবিলিটি কম। কত কম? -0.675। বুঝতে পেরেছো নাকি বুঝতে পারোনি? কি বলো?
আরেকবার যদি বলতেন।
এটা তো সেদিন আমি ক্লাসে বুঝিয়েছি যে একটা রেফারেন্স ক্যাটাগরি তোমাকে ধরতে হবে। আচ্ছা মনে করো এজ গ্রুপ মনে করো আছে 20 থেকে 30, রাইট? 30 থেকে 40, 40 থেকে 50। ওকে, এখন মনে করো প্রথম এজ গ্রুপের যারা, তারা মনে করো তাদেরকে আমি রেফারেন্স ক্যাটাগরি দিলাম 1, এটাকে বললাম 1.2, এটাকে ধরলাম 1.3। ওকে, আচ্ছা এটাকে প্রথমে ধরলাম মনে করো 1.5। এখন ইন্টারপ্রিটেশন করো তো, পারবা এটা কখন ইন্টারপ্রিটেশন করতে? আমি কম্পেয়ার, যখন তোমার ক্যাটাগরিক্যাল ভেরিয়েবল থাকবে তখন তোমাকে কম্পেয়ার করতে হবে ক্যাটাগরিক্যাল ভেরিয়েবল গুলির ভিতরে। তাহলে মনে করো 40 থেকে 50 এটা কম্পেয়ার করবে কার সাথে? দুইটার সাথে। বা এটাকে ফিক্স রেখে এই দুইটার সাথে কম্পেয়ার করবে, এটা সম্ভব না তো। তখনই সম্ভব তুমি যখন একটাকে ফিক্স রাখবা, ফিক্স কনস্ট্যান্ট, যে না 30 থেকে 40 বছরে কম্পেয়ার করব কি আমি 20 থেকে 30 বছরের সাথে, 40 থেকে 50 বছরের আমি কম্পেয়ার করব 20 থেকে 30 বছরের মানুষদের সাথে। এখন মনে করো যে আমি কাদেরকে A+ দিব, মানে কারা কাদের চেয়ে ইন্টেলিজেন্ট। মনে করো 30 থেকে 40 বছর যারা, তারা ইয়াং বয়সের চেয়ে বেশি ইন্টেলিজেন্ট। কতটুকু বেশি? 1.2 টাইমস বেশি। 40 থেকে 50 বছরের মানুষরা ইন্টেলিজেন্ট কম্পেয়ারিং টু ইয়াং এজ, কতটুকু ইন্টেলিজেন্ট? 1.3 টাইমস মোর। ইউ ক্যান অলসো চেঞ্জ দিস ওয়ান। তুমি তোমার রেফারেন্স ক্যাটাগরি চেঞ্জও করতে পারো। ইউ ক্যান সিলেক্ট দ্য হাইয়েস্ট, মানে তুমি সবচেয়ে ওল্ডেস্ট গ্রুপকে রেফারেন্স ক্যাটাগরি ধরতে পারো, অথবা লোয়েস্ট গ্রুপকে। তাহলে এখন ইন্টারপ্রিটেশন চেঞ্জ হয়ে যাবে। বুঝতে পারোনি এখনো?
বুঝছি স্যার।
হ্যাঁ
স্যার এই ক্ষেত্রে
জি স্যার,
কোনটা
বুঝতে
ধরতে
পারছি।
হবে যে
এটাই আমি বলছি।
হয় হাইয়েস্ট অথবা লোয়েস্ট, যে কোনো একটাকে ফিক্সড করতে হবে।
প্রবলেমটা হচ্ছে আমাদের যখন রেফারেন্স ক্যাটাগরি, যখন ক্যাটাগরিক্যাল এক্সপ্লানেটরি ভেরিয়েবল থাকে তখনই প্রবলেমটা হয়। আরে বাবা তোমার ভেরিয়েবল কয়টা? তোমার এখানে ভেরিয়েবল তো একটা, র‍্যাঙ্কিং না। তোমার এখানে ভেরিয়েবল কিন্তু অরিজিনালি একটা, র‍্যাঙ্কিং। এখন মনে করো আমি যদি ফ্যাক্টরটা না করতাম তাহলে কি সমস্যাটা হতো বলো তো? তুমি জীবনে এখান থেকে ইন্টারপ্রিটেশন করতে পারতা না। আমরা কি করে আসছি? আমরা কিন্তু এই র‍্যাঙ্কিংটাকে ফ্যাক্টর করেছি। কেন ফ্যাক্টর করেছি? কারণটা হচ্ছে এটাই, জিআরই জিপিএ কে আমার তো ফ্যাক্টর করা দরকার নেই, কারণ তাদের মধ্যে কোনো ক্যাটাগরি নেই। তো আমরা ওভারঅল একটা ইন্টারপ্রিটেশন করলেই হবে। কিন্তু এই র‍্যাঙ্কিং ভেরিয়েবল তো আমার ক্যাটাগরিক্যাল ভেরিয়েবল। এটাকে যদি আমি ক্যাটাগরিতে ভাগ না করি তখন তো আমি ইন্টারপ্রিটেশন করতে পারবো না। আবার ভাগ করলেই শুধু হবে না, যেহেতু আমার এখানে 4টা ক্যাটাগরি আছে, কোনো একটা ক্যাটাগরিকে আমার কনস্ট্যান্ট ধরতে হবে, যে ওর সাথে আমি কম্পেয়ার করব, নাহলে তো এখানে তো আমি কম্পারিজন করতে পারবে না। সো দিস ইজ কল্ড দ্য রেফারেন্স ক্যাটাগরি। যদি এখানে রেফারেন্স ক্যাটাগরি এসপিএসএস এ করলে রেফারেন্স ক্যাটাগরিটা চলে আসে। এখানে রেফারেন্স ক্যাটাগরি আসেনি, কারণ র‍্যাঙ্ক 1 এর মান হবে 1, কোএফিশিয়েন্ট সবকিছুর মান হবে 1। কথা বুঝতে পেরেছো? সেজন্য এটা আসেনি 1, সেজন্য তারা দেয়নি। এনিওয়ে, so could you please interpret the rank 4 in the similar fashion? Try to interpret the rank 4, then we can go in the other analysis. Quick.
Having attended an undergraduate institution with rank 4 versus an institution with a rank of 1
Good.
changes the logos of admission by
what?
-1.55.
Very good. Okay, so this is the interpretation. Okay, so this is the interpretation. Now we can go for the other topics. So now we already have the what should I say? We have the estimated coefficient. Now normally sometimes you need to show the confidence interval for your estimated coefficient. এটা কি জানো? বুঝতে পেরেছো? What is the need of the confidence interval for the estimation? Now you have only coefficient for the regression model, but I want to see the confidence interval also for each coefficient. Anyway, that's the problem. You should have a very clear idea. What is the confidence interval? Why do we need the confidence interval for the estimation? This is the basic thing. The course teacher should clearly describe you. You are learning confidence interval, but what is the need of the confidence interval? You don't know. That's the problem. Anyway, I'm just calculating the confidence interval for my estimated coefficient. That means for this coefficient, I want to see the confidence interval. How can you calculate? So confidence interval int. So this is the command, confidence interval of what? My model, my Logit model. I just ran the model, right? So try to see what is the result. So waiting, okay, you see. So the confidence interval ranges from 2.5% to 97.5%, right? So I want to know also the standard error, because you are doing the confidence interval is not enough. You just want to check the the standard error of the estimated coefficient, or sorry, the confidence interval as well. How can you find the similar fashion confidence interval? So maybe you can use default confidence interval default. So my Logit, my Logit, right? So now take a look what happens here. So what is the difference? No difference. No difference in the result.
No.
There is difference.
I think there is a difference because you are considering what? You are considering the standard. Anyway, you can explore in your home. Okay. So what are the other things there? We just finished this part now. Now we have to check here. What is this one? Can anybody tell me? What? Now, most important thing is the validity of your regression model. What is the validity, overall validity of your regression model, right? So you can see the AIC value. I told you many times in my class, you have to take a look carefully. What is the overall validity of the regression? Anyway, forget about this one. Now I want to test the overall effect of rank. What I want to test? I want to test the overall effect of rank variable for the response variable. So for this reason, you want to say, what is my objective? Overall effect of rank on admit, right? So how can you do this? For this, you need to use a statistic, wall test statistic, wall dot test. So this is the command. Then B is equal to coefficient. You already know this one. B is equal to coefficient of what? Of my Logit model. That the model you just estimated, right? You need to use some other things as well. You have to use the sigma. So this is the formula. You can check the formula of wall test statistic. I think you will find easily, right? What are the parameters you need to use? So sigma and the variance covariance matrix of the error terms. So I think you already know this one, variance covariance matrix. So you use a lot of times in multivariate analysis or the other courses in the linear regression course, or maybe the linear algebra course, variance covariance matrix of the error terms, right? So what is the variance covariance matrix of my Logit model, right? So then you need to use the terms is equal to 4:6. Any idea why I wrote 4:6? These 4, 5, 6 are the 3 terms for the level of ranks. I just hypothetically used. Okay. 4:6. 4, 5, 6 are used for the level of ranks, right? So now try to run this model. Couldn't find function wall.test. What's the reason? Any idea why it's not working?
In term,
So maybe any package for specific package for it.
Yeah, maybe we need to install a package, right? So install dot packages. So what is the package? I really forgot. Let me check. So the package may be, oh yeah, I got it. Package may be AOD. This is the one package, AOD, you see? I think it's already installed in my laptop. Library, AOD, right? Oh, no. Okay, so if you want to update something, do you know, if you want to update your packages, right? So you can use this command, update.packages, update.packages, PACK, right? AGASS. Suppose I just want to update my packages. I think this is the command you can update. Could not find the function update, right? I think the mistake in the spelling. Okay, I think it's worked now. Oh. Anyway, so it's not working. I don't know. What can I do? Unused argument. So, or maybe I can run another package, ggplot. Maybe you can extract it from the ggplot. Let's try the ggplot. I don't think it will not work. ggplot2, right? I think it's already installed here. Now I try to write library activity. Oh, now it's working. Good. So I think there is something wrong in my command, right? So b is equal to coefficient, my logic, right? Oh, I use comma sigma, right? Sigma is uppercase or lowercase?
The term may be lowercase.
Terms may be lowercase. Let's try with this one. Oh, good. I found the chi-square value. What is the chi-square value? 20.9, and the degrees of freedom 3, and the probability is 0.01. So this test statistic indicate that what the overall effect of rank is statistically significant. Why statistically significant? Because p value is significant. Clear? So what I did from this analysis, I tried to see the overall effect of the rank variable on the admission, right? So I found the chi-square test. Based on the chi-square test, I concluded what I concluded: rank has effect, or rank has influenced the admission test. So rank is a significant variable. This is the overall estimation process you can use for your research, right? Anyway, so this way you can apply the other variables here. Okay. So another thing, I told you about the odds ratio, right? You remember the odds ratio? Odds ratio, you forgot.
Yes, sir.
I told you, how can you calculate the odds ratio? Like you can just convert something. Can you remember?
Probability of occurs by probability of doesn't occur.
No, not this one. Yeah, this is also true, but how can you find this your information from it is very difficult, but you have this one, estimated coefficient. You can convert this one to have the odds ratio. Any idea?
Sir, we can take exponential of this estimate.
Very good. So how you can do this? You can just take the exponential, exp, of what? Of what?
So Logit model estimate.
No, it will not work. You have to mention what you want to estimate.
Yeah,
From the
yeah.
Logit model, you have many things are here. So you have to write the coefficient.
Yes, sir. Yes, yes.
So maybe I use before this one, coefficient. You see the coefficient? So COEF, coefficient, right? Of what? Now you can write your Logit model. My Logit my logic. You see, my logic. Clear? Now try to see. Very interesting. You see, this is the odds ratio for GRE. You see 1.002. You can see GPA 2.23, rank 2 0.50, rank 3 0.261, rank 4 0.211. Can you find the confidence interval now for its odds ratio? Can you find?
Yeah.
What? You can find
For
it?
the same way we can
The
take
same way,
exponential.
yeah. The same way we, okay, previously what we did, previously we interpreted for the normal regression model, right? Previously we interpreted for the normal regression model, but here you have to calculate ultimately the odds ratio. Here, no problem with the rank because you are using the odds. Anyway, try to explore in your home. It's look like I am teaching a first year students and they even did not know or don't know the term logistic regression. This is really unfortunate. Okay. So now I want to calculate the predicted probability of admission at each level of rank. What I want to calculate? The predicted probability of what? Of admission or admit, right? With each value of rank, right? So based on the value of the rank, holding GRE and GPA at their means. First, we create and view the data frame. So you have to view and create the data frame. So you have to build a new data frame. Mind it, we are going to predict the probability of admission. Now our estimation is to see the prediction of the probability of the admission. So you have to view the data frame again. View data frame, right? So how can you view the data frame? So you have to create a new data frame, new data one. How can you create? With function, with my data. So you have to do something with your previous data. Data is equal to data frame. Data is equal to data frame. So what was the variables in your data frame? You had GRE is equal to mean GRE because you are calculating the predicted probability. So you need to calculate mean GRE as well. In the same way, in the same fashion, you have to, for the GPA is equal to what will be here? Mean of GPA. For the same fashion, rank. Now the rank. For the rank, it will be changes because you've already converted in a factor. And factor 1 up to 4. So this is all, right? So now you can view data set. Oh, it's not working. Any problem? Tell me the problem.
The data equal to data frame, you wrote dot here.
Okay. So data frame now is working. Okay. So what is the new data frame? You can just take a look. So I am gonna find some interesting findings from here. I'm gonna see the predicted probability. What I'm gonna find here? The predicted probabilities. So that is very important for you writing the manuscript or something. So just try to take a look how I am writing. You can try in your home. So I'm gonna doing the same thing. Maybe I did it before. New data one, right? The same thing. Maybe you remember for the rank, for the factor, right? For $sign, I use a $sign. Yeah, $sign. Maybe I use a new variable P. Then because I'm gonna predict of what? Predict of my Logit analysis, right? Then what? New data. You can just follow. You can try later on. what I can do now. New data 1 or new data? I think it's not correct. Any idea? New data is equal to new data 1, right? Because I just change it. Is type is equal to response. Type is equal to response. It's working. Okay, good. So this is the another thing. I just make something here. Okay. So don't worry. It's very easy. Just try to see, because I don't have so much time. I have to finish my class. So new data. I am doing the another creation. Okay. So maybe I can copy this one. So with my data frame is GR is equal to GR. Now you have to follow some sequence, some modeling, right? GR is equal to repetition of what? Sequence, right? Oof, it's very difficult. GR is equal to repetition of sequence. Sequence of what? Sequence from, suppose 200 to is equal to 800. What about the length? Length dot out, suppose the length you are gonna see 100. Okay, so this is for the first one. Now for the GPA is equal to mean of GPA, right? Because you are gonna see the predicted value. And what's about the rank? Rank is definitely included in a factor repetition, the same way, 1 up to 4, because 4 categories are here. Each is equal to 100. So how many brackets will be here? Any idea? How many brackets? 1, 2, 3. 4 is okay, or 5? Check the code, please. Is okay or not? Please check the code. I think this will be data 2, new data 2, right? Check the code. With my data, right? Dot data frame, GR is equal to repetition of sequence, right? From 200 to 800, length dot out, right? 100 for GPA is equal to mean GPA, rank factor, repetition 1. I think it's okay. Oh, good. So now what I am going to do here, I am going to generate the predicted probabilities, the first line below, right? The predicted probability. So I want to see a plot. But for the plotting, you should construct many things again. So you have to wait a few minutes more. Just take a look what I do here. In a lot of papers, you will find this kind of graphs for the predicted probability. So now you have to combine, bind. So you have to combine new data to bind new data 2, right? New data 2 and predict what? Predict my Logit. And predict what? My Logit. New data. Hey, are you here or you are sleeping? No problem. Just try to look. What is the final output? I am looking for the final output. And what is the type? Type is equal to link. Is equal to true. Okay, let's trees work or not. Hey, what problem here? Hello.
So GPA variable is missing and the variables, something is wrong in the variable.
Say is equal to true, right? My data 3, C bind, new data 2, right? Predict my logic. Oh, predict. Okay. My logic, comma. I'm not considering any variables here. Just combine the data, whole data. New data is equal to new data 2, right? Seems is okay. Type is equal to link. And comma s is equal to true. It seems okay, but it's not running. Error in where?
Sir, you can try another line here. Predict, then use new data 3, that code.
What?
Okay, I meant you can write another line here that is predict of my logit, then comma equal using the new data 3 here, there.
Yes, and I mean that's latest video. So I'm not sure. Okay, you can think. I try to confidence interval now. I'm trying to see the confidence interval, and in the meantime, you can take a look what problems is here. Okay, new data 3, right? Then within new data, right? New data 3. So like the predicting of what? I'm not sure about the uppercase, lowercase problem. Maybe it's a problem, right? Predicted. It will be predicted, not predict. Oh. Predicted probe, right? Predicted probabilities. Predicted probabilities. Oh, I'm predicted probabilities, right? Then I have the code. Maybe I can give you the code so you can try to know. So this is the lower limit, maybe. What is the lower limit? The same thing, clock is speed. It's no problem. I'm just giving you the code so you can run in your home and try to find the accurate coding. .96. So it's very the similar concept. Suppose you are constructing your what confidence interval c dot fit. Okay, it's okay. And what is the upper limit? The similar fashion, upper limit clock is clock, the same thing, is fit, right? Fit. That was the minus. Here it will be the plus, like the confidence interval. So 1 minus 96, okay, into standard into fit. Okay, and finally the second bracket. Maybe I started with the second bracket. Where is the second bracket in the keyboard? I cannot find. Oh, okay, I did. Only 1 second bracket there because you have to close the bracket. So you see the problem with the coding. So I'm just giving you the code arbitrary, right? So what you have to do, you have to finally plot a ggplot. That means the plotting ggplot of what? Of our new data we just created. New data 3. What is the x-axis? X-axis is equal will be GRE, right? Y is equal to predicted probabilities. Y is equal to predicted probabilities. Okay. Plus so ribbon. There is a function like geometric underscore ribbon. Okay, I got the function. So geometry underscore ribbon. Here the axis will be y. Minimum limit will be the lower limit, right? And y max will be the upper limit. And fill by rank. Fill is equal to rank. Okay, here the problem with some y max, it will be the in the lower case y max. And fill is equal to rank. Only fill is equal to rank. Okay, and you have to use the alpha value. Alpha, what is the alpha value? Suppose 0.2. Okay, so then you have to use a geometric line. GOM underscore line. You can use some of the axes and color also. So the color will be in where? In the rank. Suppose based on the rank, it will be color. And finally the size. Rank size is equal to 1. Okay, so I think this is the last command of this. It will not work definitely because we had some problem already occurred. Okay, in our coding. So this is the thing. So I just want to show you the result. What I am going to do here. So like lecture. Okay, lecture. Categorical data analysis. Maybe here I have something here. Can you see?
Yes, sir.
So maybe here. Okay, this is the plot I am going to produce here. So this is the plot. You see the product predicted. So here is the GRE, right? So and the predicted probability. This is the predicted probability. GRE versus the ranking. GRE versus the ranking. So in the paper or the paper published, in the publishing paper, sometimes this plot might be very effective because you have to show the predictive probability as well, right? So for the GPA, you can also the same thing. GRE versus rank, you can also find the GPA versus rank and what is the predicted probability. So it's clearly visible in the graphs. Okay, so this is the topic today I try to learn. I try to show you the finally like the so you have the recording. So I have some errors in my coding in the last couple of coding in the last thing. So what you can do, you can copy, you can take a look in the video. So if I want to summarize, finally we had problem in the predictive probabilities, the predictive plots, right? To construct the predictive plots, we had some problem, but I gave you the code. So you have to correct the error of the codes, right? Then you have to find out the accurate or exact predictive probability of the coding. Maybe I can give you the code also, so you can just try in your home, right? I will give you the code so you can run and try to understand every coding, like in a sentence. What are the functions? What is the objective of the function, right? So the today's lecture was about what? About to fit a Logit model in a data set. So in the data set, what we had some variables. We had one response variable and we had three categorical, we have three independent variables. In three independent variables, we had one categorical variables. What was the categorical variable? The categorical variable was the rank variable. So the problem is that in rank, we have three categories. So for the interpretation of the rank, you need to factorize the rank variable. So we did the same thing. We convert the rank variable into three factors. Number 2 rank, number 3 rank, and number 4 rank. And one rank is like invisible here, but literally there was a one rank. It was used as the reference category in our logistic regression model. That's it. So we estimated coefficient first, but coefficient is not the ultimate things. We are looking for the odds ratio because we are dealing with the Logit model. So we estimated the odds ratio. Okay. Then we tried to interpret the odds ratio. Okay. So we got the odds ratio value and we tried to interpret the odds ratio for three variables. For GRE, GPA, and finally the rank. But rank had the problem. I told you it is a categorical variable. So you need to know the how to find the odds. How to find the odds ratio from your logistic regression model. Then you have to calculate the the confidence interval also for the coefficient or the log or the odds ratio. Confidence interval is important. Then what we did, we tried to find out the standard error of the confidence interval. Finally, we tried to find out the predictive probability. The predictive probability for the figure, right? So we did the same thing. Okay. So we've tried to find out the predictive probability. And at last we found a graph. The graph shows the predictive probability, right? For the response variable corresponding to the factor variables. So this is all about our today's class. So you need to learn about the Logit model. How can you use the Logit model? So in exam, some question might come. What is Logit model, right? What are the assumptions of the Logit model? Where you can use the Logit model, right? What is the purpose of using Logit model? What is the estimation process of Logit model, right? How can you interpret the odds ratio? What is odds ratio? I can give you some odds ratio and I can give you the result also. So what you have to do, you have to interpret your result. So if you don't know the interpretation, right? So I think you cannot answer in my exam. This is a very old topic, but I try to use a link function. This link function is called the generalized linear model. So sometimes you can do the same thing in the SPSS. Just you can click, you can input the data, just go to analyze, then go to the logistic regression, put the value of the dependent variable, put the value of the independent variable. You have to select the reference category for the rank. Suppose you want to see the rank 1 as the reference category. Then you will find the value. You can find easily the log odds ratio and the coefficient from your analysis. But what I did today, I tried to use a link function, or I tried to use a GLM, generalized linear model, as a function of the logistic regression model. So this is the new thing maybe you can use. So what is generalized linear model? What is the relationship between generalized linear model and logistic regression? I am not telling you, I just giving you the clue, and it's your job to explore what is the relationship between GLM and logistic regression model. Okay, I am not teaching the first year student, I am teaching a fourth year student. You have to explore by yourself. Why I use GLM in the logistic regression function? You need to explore this one. And my question will be like this: if someone can answer, he or she will get full marks or not. The university teaching should be like this, okay? Normally you don't like to read nowadays, so I think you need to explore. I'm just giving you the clue, so don't think it's too difficult. If it will be very difficult, you don't have any background knowledge. You need to understand what is the meaning of the confidence interval. At the age of like almost finishing undergraduate degree, you don't need the importance of confidence interval. You don't know really. If I ask you what is confidence interval, most of the students will not give me the correct answer, I guess, and I think you will do some mistakes over there, right? So whenever you read something, try to have some clear knowledge. Why you need confidence interval? Why you need to estimate confidence interval? Just something like this, okay? Anyway, maybe it was a very long class, but I was like playing with the codes and I had some problem with finally in the coding. Okay. So I think we should stop our class today and is trying to explore